Now that we know a little bit about how compounds are formed and how to read the formula for a compound, we're going to learn about chemical reactions. What is a chemical reaction? How is it written out? And what do all the symbols mean? So let's start with a title. Chemical reactions. First, we probably need a definition. So what is a chemical reaction? A chemical reaction is a reaction in which one or more substances are changed to new substances. So a chemical reaction is a change where you're making a new substance. You start with one thing or two things and you make something completely new. When we talk about chemical reactions in chemistry, I use the comparison of Legos. Atoms are kind of like Legos, and a chemical reaction is where you're tired of the first thing that you've built, you rip all your Legos apart, and you put them back together and make something new. All of the pieces that you started with are still there, but you've made something completely different than what you had before. Chemical reactions are written out or set up kind of like math equations. There's two sides. On the left, we have what we call the reactants. Then there's an arrow instead of an equal sign, and on the right, we have what we call the products. All chemical reactions are set up like this. Reactants on the left, then the arrow, products on the right. But what are those two things? You might be able to guess that the reactants are the substances that are about to react. And we'll put in parentheses, this is what you start with. These are your starting materials or your ingredients. What you make then are the products. The products are the new substances that are produced. So we'll put in parentheses what you make. These are the substances that your reaction finishes with. When you get to chemistry, you'll learn that there are lots of rules that go along with how chemical reactions are put together. But there's one rule that we're going to learn this year, and that is called the law of conservation of mass. Conservation means to save something. Mass is how much stuff you have. So the law of conservation of mass says that the total starting mass of all reactants equals the total final mass of all products. Everything that you start with, every piece, every building block that you start with in the reactants still has to be present in the products. It kind of goes back to the Lego idea. If you start with 10 Legos in the reactants, you still have 10 Legos in the products. You don't lose any pieces along the way. You don't add any pieces that weren't originally there. Whatever you start with has to be what you end with. You just rearrange those pieces in a different way. Next, we're going to look at chemical equations, or how chemical reactions are written out, in a little more detail. So let's start again with a definition. When we say chemical equation, we're talking about a way to write out a chemical reaction. So a chemical equation uses chemical formulas like we learned to read last week, and some symbols that we'll learn to describe a chemical reaction and the products it produces. And again, remember what we just talked about. The reactants are always listed on the left, then the arrow, products on the right. There are a few symbols that we need to learn along with this general format, and we're going to put those in a table on the next page. For our table, we'll need two categories. The symbol that we're learning, and then what does it mean? First, we had the reaction arrow in between the reactants and the products. That arrow stands for the word produces or yields. The arrow tells you that this is what the reaction makes. In between each chemical that's being combined, or in between each product that's being made, you'll see a plus sign. And a plus sign just means those two things are being combined on the reactant side, or those two things are being made on the product side. Next to each reactant or product, you may see some lowercase letters in parentheses. A lowercase s, a lowercase l, and a lowercase g. And you could probably guess that those stand for the words solid, liquid, and gas. Those tell you what state of matter each substance is in that reaction, and that's pretty important if you're actually going to do the reaction. It's kind of like having a list of ingredients, or it's telling you what to expect when you're all done. You need to know, for example, if you have to put water into your reaction, is it liquid water or do you need ice? And same is true on the other side. What are you going to make? What kind of container do you need for your products? Do you need a container that'll hold a liquid or a solid or even a gas? So it's important to know what phase each of your substances is in. There's one more that we're going to add to this, kind of off to the side here because we've run out of space. The other symbol that kind of goes along with those three is an AQ. AQ stands for the word aqueous. And you might be able to guess that aqueous is related to water. Kind of looks like that word aqua, which usually is the color of water, or if you know a little Spanish, the word for water is agua. So aqueous stands for water, and what that actually means is that that substance, whatever it's marked aqueous, is a solid that has been dissolved in water. Let's continue with the symbols that we need to know. Again, we're going to do kind of like a table. We have the symbol that we're going to learn, and what does it mean? The next set of symbols are things that you might see written above the reaction arrow. So for the first one, you'd see the arrow in the middle, and then you might see a little triangle written above it. That stands for heat. That means to get that reaction to go, or to change from the reactants to the products, you have to add heat. So we'll put heat added. Kind of like you're cooking something. If you want to get something to cook, you have to add heat. Some reactions are the same way. You might also have to add light. Some reactions are light sensitive. So instead of adding a source of heat, you would add a source of light. Or you might see electricity, which means, of course, that you need to have electricity added to get that reaction to complete. One other thing that you might see would be the arrow with a chemical formula written above or below it. Something like this. There's your arrow, and then maybe something like MnO2. There are lots of different compounds that could be listed right above the arrow, right here. This is just an example of one. But if you see that written above the arrow, that means that you're either adding a catalyst or an inhibitor. And we'll define what those words mean on the next slide. Some reactions require the use of a catalyst or an inhibitor. So what are those two things? A catalyst, start with a definition, is something that speeds up a chemical reaction without itself being permanently changed. A catalyst is not a reactant. It's not a product. It has one function, one job, and that's to make the reaction go faster. It's not a part of the reaction, it's not a reactant, it's not a product. It just makes the reaction go faster. An inhibitor, as you might be able to guess, is the opposite. An inhibitor prevents or slows a chemical reaction without itself being permanently changed. You might be wondering, when would we want to make a reaction go slower? Well, one example might be the rusting on your car. If you could make that go slower, it would make your car last longer and look nicer. Before we put all this information together, we need to review a couple of words that we learned last week. First, what is a coefficient? Coefficients are the numbers which represent the number of units of each substance in a reaction. They tell you how many molecules of this or how many molecules of that. And those are the big numbers in front of a formula. The other term that we learned last week that we still need to know is subscript. Subscripts are the numbers which represent the number of atoms in a molecule of a particular element. They tell you how many hydrogens are in the water molecule, how many sodiums are in sodium chloride or table salt. These are the little numbers that are lower than the rest of the letters. Okay, now let's look at an actual chemical reaction and put all these parts together. 4Al in parentheses S plus 3O2 in parentheses G produces 2Al2O3 in parentheses S. Let's label the parts of those reactions. First, on the left, we have the reactants. Then we have our arrow, which stands for yields or produces. On the left side then, we have products. Right side, excuse me. The big numbers in front of each of the formulas are the coefficients. They tell you how many of that molecule there is. So 4 aluminums, 3 molecules of O2, and 2 molecules of Al2O3. The little lower numbers are the subscripts, and those tell you how many of each atom is in the formula. 2 oxygen atoms in O2, 2 aluminum atoms, and 3 oxygen atoms in Al2O3. And last we have the phases. The letters in parentheses tell you the states of matter, or the phases of matter, of each of those molecules. So aluminum is a solid, oxygen is a gas, and Al2O3 is a solid. And that's all we need to know for today.